Isolation of egg albumin. Step 1. Obtain a medium-sized chicken egg. Separate the egg white from the egg yolk. Step 2. Using a pre-weighted graduated cylinder, get 10 ml of egg white and weigh. Record the mass of the sample. Step 3. Place the sample in a 50 ml beaker. Step 4. Add 2 to 3 drops of 1 normality acetic acid, then stir. Step 5. Add 3.50 grams of NaCl gradually. Then stir gently with a glass rod until no further precipitation of ovoglobulin is observed. Step 6. Let the mixture stand in an ice bath for 30 minutes to make the precipitation complete. Step 7. Filter the mixture with the use of pre-weighted filter paper. Allow it to air dry. Then, Step 8. Determine the mass of the precipitate and calculate the percent yield. Last step. Store the precipitate in a vial. Set an amount as intact and hydrolyzed protein and for qualitative color reaction. Procedure. Step 1. Add 1 ml of 10% sodium hydroxide to 3 ml of the protein suspension, then mix. Then Step 3. Mix if no definite color develops. Add another drop or 2 of the 1% copper sulfate solution. Then lastly, Step 4. Take note the intensity of the color change. Procedures. Step 1. Add 0.5 ml of 1% non-hydrogen solution to 3 ml of the protein solution. Then Step 2. Heat to boil for 1 to 2 minutes. And lastly, allow to cool. Procedure. Step 1. Add slowly 1 ml concentrated nitric acid to 3 ml of the protein suspension. Then heat gently to boil for 30 seconds. Then cool this mixture with flowing water. Step 3. Add slowly drop by drop concentrated sodium hydroxide until excess or the solution is lightly alkaline. Then note the intensification of color. Procedure. Step 1. Add 5 drops of fresh Millon's reagent to 3 ml suspension. Then carefully heat the mixture to boil for 30 seconds. Then Step 3. If too much reagent has been used, the color may disappear on boiling. Step 4. Note any changes that occur. Procedure. Step 1. Add 2 ml of Hopkins Cole reagent to 3 ml of protein suspension and mix. Step 2. Incline the tube and slowly add 5 ml of concentrated H2SO4 down the side of the tube so that layers would form. Then Step 3. Note the color form at the junction of the two layers. And then lastly, it might be necessary to rotate the tube gently to develop the color at the interface. Procedure. Step 1. Add 1 ml of 10% sodium hydroxide and 3 ml of the 0.02% naphthalene solution to 5 ml cold protein suspension. Then Step 2. After 3 minutes, add 2 to 4 drops of freshly prepared 2% NaOPr or NaOCl. Note the color. Then lastly, stabilize the color by adding urea to destroy the excess hypobromite hypochlorite. Procedure. First step, add 1 ml of 10% sodium hydroxide to 3 ml of protein suspension. Then heat to boiling water bath for 5 to 10 minutes, then cool. Lastly, add few drops of 1% lead acetate solution. Procedure. To 1 ml of 2% albumin solution, add equal volume of 1 normality sodium chloride solution. Then, if necessary, add drop by drop 1% acetic acid solution until faintly acidic to phenolphthalein. Procedure. Step 1. Place 1 ml of diluted egg albumin solution in a test tube. Then Step 2. Add picric acid drop by drop until an excess is added. Procedure. Step 1. Place 1 ml of diluted egg albumin solution in a test tube. Then add drop by drop silver nitrate of mercuric chloride until excess. Procedure. Step 1. Place in each of the 3 test tubes 5 ml of 95% alcohol. Step 2. To the first test tube, add 1 drop of hydrochloride. Then to the second test tube, add 2 drops of 10% sodium hydroxide. Then leave the third neutral. Step 5. Add to each tube 3 drops of egg albumin in the solution. That will be all. Thank you for listening. This is the Group 7 and every group member performing the experiment. Thank you.